There is a monster at the center of our galaxy, 4 million times the mass of our Sun, 26,000 light-years away, sitting at the exact gravitational heart of the Milky Way, the point that every star you have ever seen, including ours, is quietly falling around. We call it Sagittarius A star, and for as long as we've been able to look at it, it has been disappointing. Because when astronomers point their telescopes at other galaxies, they find monsters that rage. Supermassive black holes blasting out jets of plasma across thousands of light years. Cores so bright they outshine every star in their galaxy combined. Beasts that eat and announce it to the entire universe. And then there's ours. Dim, faint, quiet. A 4 million solar mass giant that produces less light than you'd expect from something a fraction of its size. For decades, the textbook answer was simple. Our black hole is a sleeping giant. It's had its meals. It's dormant now, nothing to see here. That answer was wrong. To understand why this is strange, you have to understand what Sagittarius A star is supposed to be. It is a supermassive black hole, not the kind formed by a single dying star. Those are small, a few times the Sun's mass. This is something else entirely. 4 million suns compressed into a region you could fit inside the orbit of Mercury. And we didn't find it by seeing it. You can't see a black hole. We found it by watching what it does to everything around it. For over 25 years, astronomers tracked individual stars orbiting the center of our galaxy. And what they saw was impossible. Stars whipping around an invisible point at thousands of kilometers per second. Speeds that require an enormous mass in an incredibly small space. There was only one thing it could be. That work won the Nobel Prize. And it gave us the number, 4 million suns. And nothing there to see. But here's what always bothered astronomers. A black hole that size should be feeding. There is gas at the center of our galaxy. There is dust. There are stars being torn apart. Material should be spiraling in, forming a superheated accretion disk, blazing across the spectrum, screaming its presence to the cosmos. Instead, Sagittarius A star is startlingly faint. It emits a tiny fraction of the light we'd predict. Compared to the monsters in other galaxies, ours barely registers. So we told ourselves a story. Our black hole is old. It's finished its feeding frenzy. It's dormant, a giant asleep in the dark. We were so confident in that story that we didn't watch it closely enough. And that turned out to be a mistake. In 2023 and 2024, a team led by an astronomer at Northwestern University did something almost nobody had done before. They didn't just glance at Sagittarius A star, they stared at it. Using the James Webb Space Telescope, the most powerful infrared eye humanity has ever built. They watched our black hole for a total of 48 hours, not all at once. In long, patient sessions spread across an entire year so they could see how it changed over time. They expected to see flares. Every supermassive black hole flickers a little. What they saw was fireworks. Not occasionally, constantly. The accretion disk around Sagittarius A star, that swirling ring of gas and dust orbiting the point of no return, was erupting non-stop. Not a single moment of rest. Not one. The team counted 5 to 6 major flares every single day. Blindingly bright eruptions, spewing out with no discernible pattern. And in between them, dozens of smaller ones. Faint flickers lasting mere seconds. And underneath those, even fainter changes, surging and fading over the course of months. The lead researcher described it in a way that has stuck with me. He said that in their data, they saw constantly changing, bubbling brightness. Bubbling. Like something simmering. Like something that never quite settles. And then he said something else. And this is the part that matters. Flares are expected in essentially all supermassive black holes. But ours, he said, is unique. It is always bubbling with activity. It never seems to reach a steady state. Read that again. We spent decades calling this thing dormant. And when we finally looked properly, when we actually sat and stared, we found that our black hole has never, not once, been at rest. Every observation they made across an entire year showed something different. It changed every time they looked. So the sleeping giant was never asleep. It's been twitching in the dark this entire time, and we were simply too far away and too convinced by our own story to notice. But that's not the strange part, because a second telescope was about to find something far more disturbing. Here is a problem that seems impossible. You want to know what a black hole was doing 500 years ago. Not now. Then. Before telescopes. Before anyone was watching. There's no recording, no archive, no photograph. The light from that moment left the galactic center centuries ago and has already washed past Earth. It's gone. So how could you possibly reconstruct an event nobody saw? The answer is one of the most elegant tricks in all of astronomy. And it works like this. Light doesn't always travel straight to you. Sometimes it hits something first and bounces. Around the center of our galaxy, there are enormous clouds of molecular gas. Cold, dense, enormous. And when a burst of X-rays slams into one of those clouds, the cloud absorbs it, and then re-emits it. It glows. It becomes a mirror. Except this mirror is thousands of light years off to the side. So the light that bounced off it has to travel a longer path to reach us, which means it arrives late, sometimes centuries late. Do you understand what that means? If our black hole erupted hundreds of years ago and we missed the direct flash, the echo of that eruption could still be arriving right now, bouncing off a gas cloud and limping into our telescopes after taking the long way around. We call it a light echo, and it is the closest thing astronomy has to a time machine. You are not looking at the black hole. You are looking at the reflection of its past. In January of 2026, a team led by a researcher at Michigan State University pointed a relatively new telescope, XRISM, a joint mission between NASA, the European Space Agency, and JWST, at exactly one of those gas clouds near the galactic center. XRISM does something extraordinary. It can measure the energy of individual X-ray photons with a precision we've never had before, which means it can look at a glowing cloud and answer a question that used to be unanswerable. Is this cloud glowing on its own? Or is it reflecting something? The answer came back. It was a reflection. That cloud was not producing its own light. It was acting as a mirror, glowing in response to an enormous X-ray outburst from Sagittarius A star, an eruption that happened, by Earth's reckoning, within the last few hundred years. Let me be precise about what that means, because it's easy to skim past it. Our black hole, the one we labeled dim, faint, dormant, exploded. And during that eruption, it burned roughly 10,000 times brighter in X-rays than it does today. 10,000. The researcher who led the study said something afterward that I think is the most human sentence in this entire story. He said, "I wasn't prepared for this." And then, later, we are lucky to be the first to see this flare. Not lucky to have caused it. Not lucky to have predicted it. Lucky to have been standing in the right place, at the right moment, to catch the echo, as it finished a journey that began before any of us were born. Sit with the timeline for a second because it's genuinely dizzying. The eruption happened at the center of our galaxy. That light took roughly 26,000 years just to cross the distance to Earth, so the event itself, in absolute cosmic terms, is ancient. But the echo, the part that bounced off the cloud and took the scenic route, that is arriving now, in our lifetime, recorded by a telescope that only launched in 2023, meaning, if you had been standing on Earth at the right moment, with the right eyes, the center of our galaxy would have flared. our quiet black hole would have shouted into the dark, and we would have had no idea what we were looking at. Now put the two discoveries together, because separately, they're interesting. Together, they change the picture completely. JWST tells us our black hole is never at rest. It bubbles, flickers, and erupts constantly, every single day, and has been doing so the entire time we assumed it was dead. XRISM tells us, within the last few centuries, it did something on a scale 10,000 times greater than anything we see today. So the story we told ourselves, the sleeping giant, the spent monster, the burnt-out core, was not just incomplete, it was backwards. We don't live next to a dead black hole. We live next to an active one that is feeding right now, in fits and starts, in flares and bubbles. One that, on a timescale barely longer than human recorded history, was capable of a violent, blazing eruption. We didn't catch a black hole waking up. We caught ourselves finally noticing that it was never asleep. Which brings us, inevitably, to the uncomfortable question. If it did it once, a few hundred years ago, which is nothing, cosmically speaking, could it do it again? Let's be careful and honest here, because this is exactly the point where a story like this can tip over into nonsense. Sagittarius A star is 26,000 light-years away. That is an almost unimaginable distance. Even a flare 10,000 times brighter than today's baseline is, at that range, not going to sterilize Earth. It is not going to end us. Anyone telling you a SGR-A flare is coming to kill you is selling something. But that's not really the point. The point is what this reveals about how little we knew. For decades, this black hole sat 4 million suns strong at the heart of our galaxy. And we described it as quiet, because we didn't have the instruments to see the truth. And the moment we built better eyes, an infrared telescope patient enough to stare, and an X-ray telescope sharp enough to read a photon, the entire picture inverted. Not adjusted, inverted. So the real question isn't, will it flare again? The real question is, what else are we getting wrong right now? Simply because we haven't looked hard enough yet. Tonight, if the sky is clear and you know where to look, you can find the constellation Sagittarius. And somewhere behind it, buried under 26,000 years of dust and distance, there is a point of absolute darkness that everything you have ever known is orbiting around. It is not sleeping. It has never been sleeping. It is bubbling, flickering, feeding, erupting 5 or 6 times a day, every day, and has been for the entire history of our species, while we stood underneath it and called it quiet. And somewhere out there, still in flight, still bouncing off cold clouds of gas, are the echoes of the times it screamed. We are only now learning how to hear them. If you want to keep exploring the edges of what we actually know, the questions science hasn't closed yet, subscribe to MOAT and hit the bell. A new journey through the cosmos every single week. And tell me below, what do you think our black hole does next? Until next time, keep questioning the sky.